All right, in this video we're going to talk conceptually about how we find the arc length of a curve. We're going to talk about this. This is the graph y equals x squared, and we're going to look at this green area, this green length here that goes from where x equals 1 and to where x equals 3. So we're going to find the length of this curve, or we're going to find the arc length of this curve. Now here's how we're going to do that conceptually. We're going to just realize that this curve is just broken up into an infinite number of these tiny little hypotenuses. And here I've drawn 7 or so, but in actuality there's an infinite number and each one is infinitely small. And each of these little diagonal things is actually the hypotenuse of a right triangle. So we can draw the legs just like that. And the legs are each going to be dy, which is a tiny bit of y, and dx. So conceptually, we're taking all these tiny little hypotenuses. There's all these hypotenuses, an infinite number of them, and adding up the length of all these infinitely small hypotenuses, and the infinite sum of those is going to be the arc length. Now, here's the key thing. An integral is not an area. An integral is an infinite sum of infinitely small things. So we're going to be able to use the integral to add up an infinite number of infinitely small hypotenuses this time. Don't get caught in this mindset that says integrals are areas. No! Integrals are infinite sums of an infinite number of infinitely small things. And those can be areas, they can be length. In fact, they can even be volumes, as we're going to discover later. So what we're doing here is we're taking all these infinitely small hypotenuses and adding them up to find the arc length.